All right, so you're plugged into the deep dive again. And, well, if you're here, I'm guessing you're like me. You just got to know what's happening at the edge of machine learning research. And today, we are really going deep on something that I think is really core to like the whole future of LLMs, which is how do we actually get these things to reason, like for real, with all the information that's out there?
Yeah, I mean, if you're following LLMs at all, it's obvious that they generate some really impressive text, but they're limited by what they were trained on.
Totally.
And so this paper that we're looking at, Search R1, training LLMs to reason and leverage search engines with reinforcement learning, it tackles that problem head on. And it does it in a pretty interesting way.
Yeah, and I think, everyone listening, you've probably seen these models that can kind of go out and access external information. Like, that's not completely new. But what's really cool here is it's about getting the LLM to actually learn how to search effectively as like part of the reasoning process. And they do this with RL, which is really clever, I think.
So I think, to kind of set the stage a little bit, if you think about, the current landscape, you have RG, Retrieval-Augmented Generation, where basically an LLM will retrieve some information in one shot and then use that to try to answer a question. But the thing is, it's only getting one shot at it, right?
Yeah.
And so, for a really complex problem, where you might need to go back and forth and actually search for multiple things and kind of, dig in a little bit, it often falls short.
Yeah.
And then on the, kind of the other side of things, you have this idea of giving LLMs tools.
Right.
So give them like a search engine or something that they can use.
Right.
But the problem there is to train them effectively on when to use that tool and how to use it, you often need these really huge data sets that are carefully labeled to show the LLM like exactly what to do. And that's really hard to, scale up and generalize.
It's not practical.
Yeah, exactly. And so that's where, this paper is really interesting, I think, because what they've done is they've introduced this reinforcement learning framework where the LLM actually learns to kind of autonomously decide when and how to search its reasoning.
Okay.
And the key here is it's learning from the outcome. Did it get the right answer or not?
Got it.
Rather than needing, a human to label every step of the way and tell it whether it searched correctly.
So this paper's called Search R1, and they're building on, some previous work they did called DeepSeek R1. Can you just explain, like, what is it about Search R1 that's really the core contribution here?
Yeah, so the main thing with Search R1 is it actually trains the LLM solely through reinforcement learning to generate multiple search queries as it's reasoning.
Okay.
So it's not just adding on a search function. It's really integrating this searching as part of the thinking process.
Oh, wow.
So the LLM is actually learning to kind of actively probe for information that it needs, kind of like you would if you were researching something.
So like as it's processing this question, it might be like, okay, I need to know more about X, and then formulate a search query about that.
Exactly, yeah. And so because, training these LLMs with reinforcement learning can be kind of tricky, right?
Yeah.
You want the learning to be stable, and you want it to be kind of focused on the right things.
Yeah.
They use this technique called retrieve token masking. And what that does is it basically focuses the learning on the text that the LLM itself generates, rather than trying to directly optimize the content that it gets back from the search engine. So it's about the LLM learning how to use those search results effectively.
Okay, so not necessarily trying to change what the search engine returns, but like understanding how to navigate those results.
Yeah, exactly. Yeah.
Okay, and so what kind of feedback is the LLM getting? Like, how is it learning? What's guiding that process?
Yeah, so they actually use a really simple reward. It's basically just based on the correctness of the final answer.
Oh, interesting.
So the LLM is basically being incentivized to just get the answer right.
Yeah.
And it's learning that searching effectively is kind of a way to do that.
I see.
And there aren't any rewards that are based on specific search actions or steps in its reasoning. It's all about the final outcome.
So it's almost like just figure out how to do this, and we're just going to measure on whether you got it right or not.
Yeah, exactly.
And so did it work? Like what actually happened?
Yeah, so the results are pretty impressive.
Yeah.
Across 7 different question answering data sets, Search R1 actually showed some pretty big gains compared to, kind of existing state-of-the-art methods.
Wow.
So we're talking about like average relative improvements of, 26% over Quinn 2.57b, 21% over Quinn 2.53b, and then 10% over LaMMA 3.23b.
Wow, those are big numbers.
Yeah, so it's a pretty substantial jump in how well these LLMs are able to answer these questions.
Yeah, that's awesome. It really shows like the potential of this whole like really integrated reasoning and search.
Yeah.
And it sounds like the paper goes like beyond just those performance numbers too, and actually kind of analyzes how this learning happens.
Yeah, definitely. So it gives some, really useful insights into kind of the dynamics of reinforcement learning optimization in this context.
Yeah.
It looks at, how different LLM architectures kind of respond to this training. And it even looks at things like, how the length of the LLM's response changes as it's learning how to use this search and how to incorporate that into its reasoning process.
Cool.
So it gives you a kind of a deeper understanding of what's going on.
Yeah, that's awesome. Okay, so maybe let's step back a little bit and talk about like the history here. How have we gotten to this point of trying to equip these LLMs with some knowledge of what's out there?
Yeah, it's definitely been an evolution. Kind of early on, the simplest way was to just take some retrieved text and just feed that directly into the LLM as input.
Got it.
But the problem is it's not really integrating that information into the reasoning process.
Right. It's just like dumping a bunch of documents on your desk and saying the answer's somewhere in here.
Right. Exactly.
Yeah.
And so then, kind of RAG came along, right?
Right.
Retrieval-Augmented Generation.
Right.
And that was kind of a, more structured way to try to augment the LLM's knowledge.
Yeah.
But the problem with RAG is that it usually just does this one-round retrieval.
Right.
So, for a really complex question where you might need to kind of go back and forth and explore, different pieces of information, it's just not as effective.
Like imagine trying to solve a puzzle and you only get to look at like one clue.
Exactly. Yeah. And so then, that's where this idea of giving the LLMs tools started to come in, like search engines and things.
Right.
But then the problem there is, how do you train them to use these tools effectively?
Yeah.
And that's where we get into, needing these really huge data sets and all this kind of stuff.
Got it.
And so then we come to reinforcement learning, which, there's been some work in the past, including, DeepSeek R1, that's shown that RL can be really effective at, improving the reasoning capabilities of LLMs.
Right.
And so what Search R1 does is it basically takes this idea of using RL and kind of extends it to this problem of, searching and retrieving information.
So the key thing here is that it's not just that the LLM has access to a search engine, it's that it's actually learning how and when to use it as part of its reasoning.
Exactly.
And all just based on that simple reinforcement learning reward.
Yeah.
Okay. Wow.
So it's really learning this kind of search strategy.
Okay.
And I think the fact that it gets these improvements across these different LLM architectures like Quinn 2.5 and LaMMA 3.2 is a really good indicator that this framework is actually pretty robust.
Right.
And it's not just tied to one specific type of LLM.
Right.
And then also I think it's kind of interesting that it even learns to kind of self-verify its answers through additional searches, which is a pretty, kind of emergent behavior that they saw.
Yeah, that's cool.
That it wasn't, explicitly programmed to do that. I kind of figured that out on its own.
So I guess thinking about like what this actually means, what are some of the real world implications of this? Like what could this lead to?
Yeah, so I think one of the most obvious things is you can have much more accurate and reliable question answering systems.
Yeah.
That are able to tackle these really complex questions that require sifting through lots of information.
Yeah.
So you can imagine AI assistants that are giving you much more insightful answers in research or education or lots of different fields.
Or just research tools that are able to actually go out and kind of gather that information and filter it for you.
Exactly. Yeah. And even beyond research, any kind of domain where you need to do some complex reasoning based on, up-to-date information.
Okay.
And you don't necessarily have, these knowledge bases that are kind of pre-compiled for you.
Right.
Um, you can imagine things like enterprise search or knowledge management within organizations, where the LLM is actually able to dynamically retrieve that information and reason about it.
So instead of having to update knowledge graphs and stuff, it's going out and getting the latest information.
Exactly.
Okay.
Yeah.
Very cool. All right. So now for our novel notions session. This is where we kind of like to think about, based on this work, what are some interesting future directions or extensions that this inspires?
Yeah. So, given, how well Search R1 does at actually learning to search autonomously with, a fairly simple reward, one interesting direction would be to try to integrate some measure of uncertainty into the LLM search strategy.
Okay.
So you can imagine, the LLM is trained with this approach, right?
Yeah.
And it gets asked some question, and maybe the initial search results that it gets back are kind of ambiguous, or they're contradictory,
right? Or
maybe they just don't seem very reliable.
Okay, so it's not getting a very clear signal.
Yeah, exactly.
Yeah.
And so if there was some way for the LLM to actually estimate how uncertain it is or how reliable that information is, then it could actually, use that to kind of dynamically adjust its search behavior. And so, maybe it would, if it detects that there's a lot of uncertainty, maybe it would try to formulate, more specific queries, or it would try to explore different search engines or different knowledge sources if it had access to those.
Got it.
Or even, in a more interactive setting, you could even imagine it, asking a user for clarification.
Oh, interesting.
Right, if that was possible.
Yeah.
But the basic idea is that, the reward would still be based on, the accuracy of the final answer.
Right.
But the learning process would actually, kind of encourage it to adopt these more robust search strategies when it's faced with this kind of uncertain information.
So it's not just searching, it's like it's being critical about the search results.
Yeah, exactly.
That's cool. Any other kind of future directions that come to mind?
Yeah, I think another really interesting one that would kind of push things in a little bit of a different direction would be to explore this idea of collaborative search, where you actually have multiple LLM agents that are kind of working together.
Oh, wow.
So you can imagine, you have some really complex research question or some problem that you're trying to solve.
Right.
And it could benefit from, having, different perspectives, on kind of gathering and interpreting information.
Form of AI researchers.
Exactly, yeah. And so you could potentially, extend this Search R1 framework so that you actually have multiple LLM agents, and maybe they're each kind of initialized with slightly different parameters or even, slightly different kind of biases in their initial search strategy.
Exactly.
But they would all kind of independently perform this interleaved reasoning and searching on that same underlying question. And then, you could have some mechanism for them to kind of, compare notes.
Uh-huh.
So maybe they have, some kind of shared memory, or there's some kind of, central coordinating agent.
Okay.
And then they could kind of, evaluate the relevance and reliability of their combined findings.
Yeah.
And potentially even, identify areas where they agree and disagree.
Right.
And then ultimately kind of converge on, a more robust and kind of well-supported answer.
Interesting.
And then, the RL reward in that case could be based on, the collective accuracy or completeness of, the group's findings.
So almost like how human research teams, kind of operate.
Exactly.
Bringing in different expertise.
Yeah.
That's awesome. Well, it seems like, this Search R1 is really kind of a big step.
Yeah.
Not just in terms of, improving how LLMs access information, but really in how they reason and learn.
Definitely, yeah. It's pretty exciting to see, how RL is kind of pushing things forward in terms of, developing these more autonomous and intelligent AI systems.
Yeah, for sure. So for everyone listening, if you want to dive deeper into this, we'll have a link to the full paper in the description.
Definitely worth checking out.
Yeah, absolutely. But it really gets you thinking, right? Like as these LLMs become more and more capable of kind of learning to find and reason with information on their own, what kinds of new possibilities does that open up?
Yeah, I mean, how will that change the way that we interact with knowledge and solve these complex problems?
Yeah.
I think those are some really interesting questions for the future.
Awesome. Well, thanks for joining us for this deep dive into Search R1. We'll catch you next time on the deep dive.